All right, good evening, everyone. Welcome once again to. I think this should be our 20th contact in looking in the tribute camp. Um, I think there was something to complain about the exam time people that just came out, and yeah, we're going to make sure we the boot camp is going to be rounding up most likely before the exams begin. Right, I think the exams are supposed to start 30th of October. Or plus or minus, we should be done with the boot camp officially next 2 weeks, and then be giving like the final project that students are supposed to build. So that should be like if I check my calendar, I think uh we should be done by the last class will be holding on 5th of November 2023. That's when our last class is going to be holding. So we can just space the day a bit till that happens. All right, so today we're going to be looking at a very important topic. We're going to be looking at smart contract testing. That's writing tests for your smart contracts, and it's a very very important topic because, especially when it comes in the Web3 world, right? Sorry, there a lot of background noise coming from my end. Is there a lot of background noise coming from my end?
It's not really much. It's okay.
Sorry about that. I had to stay outside because of network. So I'm currently out on my room. Apologies for that after. Yeah, so I'm just going to share my screen and we are going to get started. All right, you guys can see my screen, right?
Can see your screen.
Okay. Okay, so we're going to be using this article from Ethereum.org. I'm just going to put it in the chat. It's very important, like you go through it later, probably after the class. And so now testing, writing tests basically are very important, especially like in a complex field like the blockchain, right, where your smart contracts, your codes are immutable. So it means that once your codes are deployed on the blockchain, right, they are not susceptible to change. And if they tell you that an action you take cannot be reverted, right? The thing that comes to your mind is okay, I have to make sure that this action I'm taking is the right one. You go through a lot of thinking to ensure that okay, at this point, I hope I'm not making a mistake, right? So that's just how it works. So if you're going to be deploying an immutable contract to the blockchain, it means that I have to make sure that this contract is safe and this contract is not exploitable. Testing is even a very big deal in Web3, mostly because literally every smart contract within the Web3 world, right, is handling people's money, like most of them, right? So imagine if you are deploying the next Uniswap or the next compound or the next Aave and you are handling millions of people's money, millions of dollars, and then there's a bug in your smart contract. We've seen it happen time and time and time again, where like big smart contracts are hacked and people lose a lot of the protocols, lose billions of dollars, right? That can be very depressing to you as a developer, the owner of the company, the founder, whatever it is, right? Even down to the users, right? There's a lot of pressure on everybody, and that's the reason why testing it's not a very small deal in like the Ethereum world. It's something you need to like take your time to really master. uh Basically it's not just about writing codes, right? It's about writing safe codes, and how you write safe codes is by writing like robust testing suites, right, to ensure that okay, my codes are truly risk free or bug free. All right. So basically there are contract upgrade patterns that exist obviously. For example, there was this protocol, I can't remember the name, right? So what they did was when they deployed their smart contracts to the blockchain initially, they made it upgradable for the first 6 months. So the whole idea is in the first 6 months, we're going to look at the smart contracts, right? And if there are any bugs found or anything, right, during the usage, developers can quickly push a fix. But contract upgrading is like a very delicate thing in Web3. It requires what we call a social consensus. For example, if you're going to be upgrading the contracts, right, you need a DAO, you need people that would vote for the upgrade, you need people that would decide if this upgrade is worth it, right? Because imagine if you could change smart contracts anyhow you like. It means these smart contracts have lost the key property that made them unique and made them safe and made them trustless, right? And that's the fact that they are immutable. So if you're going to upgrade this contract, what stops the developers from probably adding a bug that can steal users' money or adding a backdoor, right? So these are some of the reasons why upgradable patterns are still not very widely accepted by the community. Although we're still going to be teaching you to build upgrade, I think after the next two testing classes, that's today and Sunday, next week, you're going to be looking at upgradable contracts. All right, so just moving on, right? So these are the reasons why writing smart contract tests are very important. So what exactly is smart contract testing? So smart contract testing is like the process of verifying that the code of a smart contract works as expected. So that's just the simple thing you are doing. You are saying, okay, I wrote this code, right? This was the initial thing I had in mind writing this code. Because basically when you write codes, you think about it, you have this logic planned out and you're just putting down your thoughts in codes, right? The whole idea of writing tests is to ensure that okay, these ideas I had, I hope my codes execute the right thing, they work as I expected it to work. And that's where they are useful because if you write good test suits and your test passes, it gives this feeling of reliability, gives this feeling of security, right? And that's why testing smart contract testing are important. So we already talked about why they're important. Right? Let's look at the different methods for testing smart contracts. So there are two major methods for. Sorry, I don't have an assistant in this class. So if you have any question, use the chat. I'll be reverting back to the chat from time to time to like check it out. Just use the chat if you have any questions. All right. So why is smart contract testing very sorry, what are the different methods for writing for testing smart contracts? So there are a lot of methods, right, for writing tests, but they are categorized into two major categories. We have automated testing and we have manual testing. Automated testing and manual testing, like they have different benefits and trade-offs. But basically, the safest way to build like a very safe smart contract, right, is to combine the both of them to like create a very good plan for analyzing your contracts. So what's automated testing basically? So automated testing is simply the use of like tools that are created to automatically check your smart contract code. Example are writing scripts, using fuzzers, using static analysis tools, and so on and so forth. So basically, these are you write scripts. For example, what we're going to be doing in today's class is automated testing, right? So we're going to write scripts that are going to be run against our smart contract, and if the test passes, right, you know that okay, our smart contract is safe, and so on and so forth. So, but the problem with automated testing is you need to like make sure that your coverage is very well. We look at what coverage is, right, in testing, but you need to make sure like your coverage is extensive. If not, there you might miss certain bugs and produce what we call false positives. So, but manual testing is a little bit different, right? It's basically human aided. So I don't know if you've heard about smart contract audits. You've probably heard about smart contract audits. You've heard about bug bounties and stuff like that, right? This is where like these things fall under manual testing. So basically, manual testing is human aided and involves executing each test case in your test suite one after the other while analyzing a smart contract correctness. So it is unlike automated testing where you can simultaneously run multiple isolated tests on the contract. and get a report showing all failing and passing tests with manual testing. You probably need to like do these things individually, right? Analyze them individually to ensure that they actually work as expected. So because of time, we're going to start with looking at automated testing. So automated testing can be divided into two major categories. The first of them is what we call unit testing. Unit testing. So the second we're going to be looking at is integration testing, right? We're going to be starting with unit testing. So unit testing basically evaluates contract functions separately and checks that each component works correctly. So with the unit testing, you're basically like testing the functionality of every single function contained in your smart contract. Okay, the test to transfer, does it work as expected? Does it deduct the balance of the sender before he sends the money? Sorry, before the recipient is credited, right? Is the recipient credited the right amount? All these things are the things you test for unit testing. You test each function individually to ensure that they do what they're expected to do, that they work correctly. So they are very useful, right, for checking functions, checking that functions return expected values, and that the contract storage is updated properly after function execution. So the guidelines for unit testing smart contracts. So let's say I want to write a unit test, right? What are the guidelines I need to follow? How do I get started? And the first is you need to understand your contract's business logic and workflow. Now, this is actually very important because you can't write tests for a smart contract you don't understand. Remember what I said earlier? First of all, before the developer writes the code, right, he has something in his mind. So that thing in his mind is what he puts into code. Now, the whole idea of testing, right, is to check that the code conforms to what the developer has in mind. So the code works as expected. So it means that for you to write proper unit tests, right, the first thing you need to do is to understand your contract business logic. You need to understand how the contract works, how they interact with each other. You need to understand the workflow in general. So you can definitely do that by going through the contract. You can go through the contract, read through it. Most developers, for example, when you as a smart contract auditor, right, which maybe one or two persons from here might decide to do. So it's a very and it's a very amazing field, but it takes time to build experience, like a whole lot of time. You need to become a smart contract developer first before you go into auditing. Auditing is like a big deal and earns a lot of money, right? But then you need to be very careful because you are securing people's livelihood. So back to where we are, right? So the first thing you need to do is you need to go through the smart contract. So let's say the smart contract was written by you, then it's we assume you have a good idea of the business logic. But if it's not written by you, then you probably need to go through the smart contract to understand what like the developer who wrote it had in mind. And there was a simple example given here, but we'll probably not go through it because of time. The second thing you need to do is you need to evaluate that all assumptions evaluate all assumptions related to contract execution. So next thing is you need to understand write unit tests to verify the validity of those assumptions. For example, let's say in a simple PR620 contract, right? In terms of time, we're not going to go to their own example, but you could also check, like I sent the article link earlier, so you could definitely check it to like gain more understanding. But let's say for because we're going to be working with an ERS20 contract for this particular class, right? So let's say you're trying to like test and your expensive contracts, right? So you need to try to like evaluate all assumptions related to the contract execution. For example, you say you can think of stuff like, okay, when I call the transfer function, what is expected to happen? Okay, it is expected that the balance of the sender, the person sending the money is deducted, right? And it's expected that the recipient receives the right amount. So it means that all these things have to happen in order for this test to pass, in order for you to assume that this contract works correctly. So the same thing happens with transfer from. You need to ensure that okay, we want to assume that the owner approved this particular person trying to send this to actually send this amount of money, and so on and so forth, right? So you need to have like a good idea of the assumptions that are related to that particular contract execution. And so the third thing you need to do is you need to measure code coverage. Now, code coverage is very, very, very important. It does not 100% guarantee that okay that your contract works correctly, right? But it's a very important testing metric. And I'm going to teach us how we can use a code coverage tool, right? Which is popularly used. So we're going to use the code coverage to check like how many lines. So basically, what code coverage does is it goes through your code, right? Runs a test against them and tries to check like how many lines, how many branches, statements in your code, blah blah blah, like was really executed during the test. So if it was executed during the test, we'll assume that okay, the test covered this part. So it's very important to like actually measure your code coverage during testing. Then the fourth important part is you should use well-developed testing frameworks. This one cannot be overemphasized, right? So when you're running tests, you should ensure that you're running it with very quality tools. For example, you need to use testing frameworks that like are regularly maintained and you and have been shown to like have good reputation, right, in like the ecosystem. So you should try to use tools that are extensively used and have been vetted by other developers. So most testing frameworks you would see are mostly in JavaScript, Python, and Rust. But thanks to Foundry, right? Foundry gives you the ability to write tests in Solidity. And initially, because we didn't want to confuse you guys, right? We wanted to just stick with Hardhat for this class. But I thought about it, right? And I realized that going on the right, most persons usually switch to Foundry because of its large testing options, right? You probably use both of them hand in hand, Hardhat and Foundry. But on Sunday we're going to be doing a Foundry crash course on Sunday. It's going to be covering an introduction to Foundry and how to write your test in Solidity with Foundry. So just prepare for that in advance. So as I was saying, right, most testing frameworks gives you the ability to write your test in that JavaScript, Python, Rust, and Solidity, depending on what you are like familiar with. So, for example, we have Truffle. Truffle is very popular, but Truffle has been deprecated. I think I saw a message from Consensus like few weeks ago, right? So Truffle itself has been deprecated. I don't think it's currently managed, but you can run unit test with Truffle. I think Truffle is in JavaScript. You can run test with Brownie. Brownie is in Python. Foundry is in Solidity. Waffle is JavaScript basically. Remix. I would not advise you to use Remix ID. There's also the Ape framework. I think that should be in, I'm not sure, either JavaScript or Rust. I don't know. I've never used it. And there's Hardhat, which is in JavaScript and which is what we're going to be using for this particular class. I don't know if there are any questions. Okay. Then for the integration testing, right? So integration testing is similar to unit testing, but very different from unit testing. Because while unit testing would debug contract functions in like isolation. Like I said, you test each function in isolation. Integration testing more or less covers how like your contract or the components of your contract interact with one another. This is very useful when you are probably your contract has a modular structure in like large contracts, for example. You don't want to write all the smart contracts in one file. So you probably like break things down into different parts and you'd have different modules, right? That's what cover, and basically one might inherit from the other, and so on and so forth, and one might be dependent on the other. So in this case, you run integration testing, you check how these different components interact with each other. Okay, without going far, a good example, right, is let's say running test for your what's it called? Um the Oracle contract we covered few weeks ago, right? So that's a good example of integration testing because I think the first time I wrote tests for like an Oracle related contract, right? You probably need to like get this what's it called again? They're more like dummy contracts, right? Or yeah, basically dummy contracts you can interact with from Chainlink, right? And you probably need to check how your contract interacts with this. So these are like examples of integration testing. and they're actually very important. They're actually very important. So while you run your tests, you need to run integration tests to ensure that your contract interacts properly. So let's say your contract is calling other contracts, right? You need to check all these things. And most times you need to do this right, you need to like run a local fork of the blockchain. And currently I think the two most popular Ganache, which is also offered by Truffle, and Hardhat, which is the Hardhat local blockchain, which is from Hardhat, obviously. This can be used to like simulate interactions between your contracts and deployed contracts. So integration testing is actually very important. Then we have what we call property-based testing. Now these other parts we're going to be looking at, I would say, are a little bit above your skill level, right? But with time you begin to like come across these, you begin to like learn to use these tools, right? Because they're actually very important. So property based testing is more or less like the process of checking that your smart contract conforms to certain properties. For example, checking integer overflow or underflow, checking arithmetic operations and stuffs like that. Now, property-based testing is divided into like two major categories. We have the static analysis and we have the dynamic analysis. So basically both of them like achieve two different things, but you probably love dynamic analysis more. So they are like very two common techniques, right, for executing property-based testing. Now let's just look at static analysis. Let's see how static analysis works. So a static analyzer basically takes as input the source code of a smart contract, outputs results declaring whether a contract satisfies a property or not. So most static analyzers, right, they come with default properties, right? And there are also others that gives you the ability to like specify your own properties. And all they do basically is they run your smart contract and they like more or less like compare to see if like your contract satisfies the outlisted properties. And if it don't, like basically they're going to output like a little file that has the results declaring whether like the contract satisfies the property, and if it does not, like the properties that are not like satisfied by your contract, right? So there are two common methods which are linting and static testing. We're not going to be covering all these ones. Like I said, it's very very advanced for like your current level, but it's there are stuff you would encounter going forward. Then we have dynamic analysis. So dynamic analysis generates symbolic inputs, and um, dynamic analysis can either generate symbolic inputs or concrete inputs. Symbolic inputs, example in symbolic execution, I've not tried that. But then there's also the concrete inputs, which is, for example, is the popular fuzzing technique, right? The fuzzing is a very popular example of dynamic analysis. And I don't think it's available in Hardhat. You probably need Foundry to do that. So the whole idea of fuzzing basically is you are calling or invoking functions, right, with random or malformed variations of the defined input value. So let's say your function basically takes in integers. You can decide, okay, I want to like force my contract with integers from 0 to like 1,000 or so on and so forth. So the whole idea of forcing basically is to provide a lot of random variables, right, that you probably not have done if you had like written the test manually, and to check that, okay, that these values do not break your smart contract. So if a value, a variable is supplied which breaks your smart contract, right, or which makes your smart contract to malform, first thing is going to like at the end produce like a report that contains the particular function that was broken and the input values that was supplied that like broke that function. The first thing is very useful. It's very useful, right? You're going to like you are going to use it a lot. You're going to find it very important, and that's the reason why I want us to cover the class on Foundry on Sunday. It's going to be a very brief class, because we cannot cover the whole of Foundry in one class, right? But hopefully it's going to be very helpful. So there are very important, many important reasons why people use fuzzing. The first of them is writing test cases that cover many scenarios. It's very difficult. So imagine, like I said, you want to write a you have a function that accepts integers, right? You can't supply from zero to like a million integers, right? And let's say what if 230 something would have broken your smart contract and you tried it with 10, you tried it with 15, you tried it with 20, you would probably not have known that if you supply 2350 is going to break your contract for one reason or the other, right? You probably not have thought of that, but that's what Wear Foundry helps you just automatically like supplies different inputs. You can definitely pass in a range of data like tell us 400, okay, I want to pass in a range of integers between this and this, right? And the program will automatically generate test cases based on your defined range of data, your defined property. The second reason why a lot of persons use for forcing, right, is because your test suite may not sufficiently cover all possible parts within the program, even if like probably you run your code coverage and you said you covered it 100%, there's still a possibility of missing out very little edge cases. With all these, unit test proves a contract executes correctly for sample data, but whether the contract executes correctly for inputs outside the sample remains unknown, which is just similar to what I explained, right? So your contract accepts integers, right? Fine, that's cool, and you supply positive integers and they work. But you probably not have known that maybe supplying a negative integer would have broken your smart contract or something. So that's where fuzzing comes in, right? So it tries a lot of values and finds what breaks and what works. So there are different guidelines for running property-based testing for smart contracts. Please, you could just run through these. They are very easy to understand, and you could check out the different static analysis and dynamic analysis tools available. So there's Slita, which is very popular for static analysis. There's property-based testing with Brownie. I've never used that. There's fuzzing contract with Foundry. That's a lot of persons favorite. There's also Echidna also provides fuzzing. Then there's symbolic execution, which I've not tried. You could do that with Manticore and Nitro. Now into manual testing, right? So I already defined manual testing earlier. So manual testing basically comes in at the later part of your testing phase. Think of manual testing as the phase two. So like I said earlier, you could decide to do one of the two, right? But to ensure that your smart contract is like 100% secure, which it can never be, right? But to obtain or to achieve optimal security is necessary that do a combination of both automated testing and manual testing. The manual testing basically comes in the later development cycle. That's after you've run automated tests. So this form of testing evaluates the smart contract as one fully integrated product to see if it performs as specified in technical requirements. So one thing you probably want to do, right, which is very important, is like to test your contract on a local blockchain or a testnet. So probably been doing things locally and they've been working fine. Or most times, if I even the testnet environment has very little disparities between it and like the mainnet environments, right? So, but to achieve optimal security, right, you want to like try test out your contracts on like a local blockchain. I give us some examples, Ganache and Hardhat. You want to try them on testnets, right? I even advise you try them on testnets. They're actually very important because testnets are like the closest you have to like the main blockchain, right? To mainnet. So it's very important to try out testing your contracts on testnet and stuff. Um, and there's stuff on testing versus formal verification. Verification is like way over your level. I don't think like it's something you want to bother about at the moment. But it's more or less like the whole idea of formal verification is like to assess the correctness of your software by checking whether a certain formal mathematical model of your program matches the formal specifications is actually a bit too complex and also very expensive to perform. I don't exactly know much about formal verification, but it's something a lot of smart contracts try also. Now, testing versus audits and bug bounties. Now, these are some other things you could probably do, which is very important. Like I said, this belongs in the manual testing phase, right? So you've written automated tests, everything seems to work well, but you want to put out your contract to like professional audits, audit firms, right? There's Open Zeppelin, which is very popular. There's a lot of them. I can't remember now. Cetic and don't test with Cetic. I don't know. Cetic has okay. That's not a good thing to say, but there are a lot of them. Basically, you could just check out smart contract audit firms. There are also people we call solo auditors. So these guys are they audit solo, right? And they could help you always go through your smart contracts. And there's also the bug bounty thing, which is actually very popular in the ecosystem. So ImmuneFi is a very popular bug bounty platform, and the whole idea of bug bounty is more or less like, all right, I feel like I've written this smart contract and I'm sure it can be broken, but fine, I'm putting like a bounty of $1 million on my software. So if anybody can find a bug that will break this software, right, report it to me and you get $1 million. So we have people in the system called white hackers, right? So white hackers are basically people partake in bug bounties, they find bugs and they report to like the companies that own those contracts, right? So white hackers are going to get involved in the bug bounty. They're going to try to find bugs, and if they find any bugs, right, they would report to you and take their money. If they don't find any bugs, then you save your money, and you hire the best developers. And so I think that brings us to the end of our introduction to testing. There are different unit testing tools, integration tools, property-based testing tools. Check out all these things. There are also tutorials to use most of all these tools. I already sent the article, so please check it out later. And I think that would be all. Now we're going to go into the practical aspect of writing tests. I don't know how many of us use our laptop. If you want to follow your laptop and you want to follow like the class, I will advise you do so. So you probably run into issues, and we could try debugging them together. All right. So what we're going to do is we're going to start a new Hardhat project. Obviously, where do I want to do that? Let's just open something. All right. So we're going to start with installing Hardhat. So run npm init packing and testing class version 1.0. Let's just keep all this. Mm. Yes. All right. So the next thing we're going to do, right, is to run the Hardhat installation command. What's that again? Hardhat. Yeah, npm install see if they've Hardhat. And I forget that. Npm install the Hardhat. Ah, I've probably done this in advance because my network is not like very strong. So let's see. Let's wait and hope this gets completed. Right, so while we for that though, is there anybody following like the um anybody with their systems who want to follow the class practically? Anybody you could just use the thumbs up. Okay, there's Henry. Just Henry. All right, I guess it's just Henry. Well, for the rest, you could probably try later. Probably the rent recordings are made available. Okay, let's wait so this thing gets installed and we could just proceed. All right, so we are done with installing this, right? So I'm going to bring up MPX Hardhat and I'm going to create a JavaScript project. Yes, yes. They want to install, yes. Sorry about my network. Hopefully this would finish tonight and we'll get started. So, but if you already have your stoves installed, right? You can just head to my GitHub just you get the smart contracts we'll be using. Um, I just find it here. Right, so we're going to be using the token.two contract. It's like a very simple Solidity ERS20 contract. And that's what we're probably going to run our tests against. This is done. Nope. All right, it's finally done. So I'm going to just open this in our code editor and we could get started. I don't know, can you see my font size or do I need to increase it? Let's delete this. It's going to affect our code coverage. Do I need to increase the font size? No one is seeing anything.
Yes, please.
You guys, like, all right, all right. Um, let's just 16. Let's see how 16 looks like. I think this should be okay now, right? Look,
It's
guys,
better now.
all right. Yeah, so this is the arithmetic contract from one of our previous classes. You could just check my gist in case you don't have access to it, right? But this is what we're going to write in our test again. So we're going to try to like test that contract. All right. So it's a simple arithmetic contract. He has the transfer approved, transfer from, transfer means, and so on and so forth, right? So the first thing we're going to do is we're going to go into our test folder. So all your tests basically goes that's if you're using Hardhat, right? All your tests will go into like the test folder as you can see here. And we're going to create a new file which we're going to call ers20.js. It's good practice to like name your test files like same as your contracts, right? So probably with the .js extension rather than .sol. So once we do that, what I want us to do, right, is do we have any not package.json, how do I configure.js? So let's try to. We're not going to be doing any deployments. We're not going to be deploying our smart contract. So I think this should work right. The only thing we're going to be installing at some point is we're going to be installing like our code coverage tool. But aside that, I think we could just compile our smart contract and going to do that using the npx Hardhat compile command. And once we have that compiled onto a zip file successfully, all right. So once we've compiled that, right, we can now get started. All right. So the first thing we'll probably be doing is we're going to be importing the task package from Hardhat. I think from Hardhat. Okay, so this JavaScript basically this should be constant meters force require Hardhat. All right. Yeah, someone asked me a question. Did I? Right, so no problem. The call is going to be recorded. We could probably reference it later. All right, let's just proceed, right? I think we'll be needing the task package. We'll probably be needing let me check something. I've actually forgot the name of this package. Testing contracts, right? There's something in particular I want. What's it called again? Yep, the load fixture. Yep. And the expects require from child. So basically needing the load fixture, I will explain what this in particular does, right? And we're going to be using the expects from child. So I think we'll probably need to go through that. So we're going to need this, and finally we're going to need the what's it called again? Load fixture. You can get that from Economic Foundation slash that should be network helpers. Okay. So basically it does is I think you're really familiar with JS from the previous classes, right? So going to be needing that to do some to access some specific stuff like deploying our contracts. So but these like data that's packaged with Hardhat. Then we're going to be importing the expect method from Chai. So Chai is like what should I call it? More like think of it as like a testing framework. I think it's usually bundled with Waffle. Let me check if I have that here. So I'll probably send that. And you they're actually very important for testing, right? Yeah, one of the mm, very important modules we're going to use for writing tests, right? And they have different methods available, right? You could use, I think there's expert, there's assert, and there's a whole lot of them, right? But for the purpose of this class, I'm probably going to just be using the expert and like the assert. So when you start testing your smart contracts, right, the first thing you want to do is to use the describe method or describe keyword um, that comes from Waffle, right? So the describe basically is what you would use to like describe your it's basically what we use to like categorize your tests. So let's say you want to break your test into different categories. For example, the deployment, you want it to be one section. You want to break the ones on the transfers into one section, and so on and so forth, right? You would use describe for doing that. And basically how you do that is, for example, I'm going to say describe token deployment, right? I'm going to call this particular test fixture to token deployment. And this particular function is not going to be an await function since it's not going to be an async function, right? Since we are not going to be using any await call. Then in here, right, we are now going to specify it's within your describe. You now begin to like specify your tests categories. For example, you do that using the it. basically the it method from Mocha from Waffle from Mocha, right? So basically, this is how you like describe your test specification case, and you usually use a callback that is an async function to like write your test in it, right? So you do stuff like okay, it deploys token stuff like this, right? And then you do like an async function, separate user functions, right? Do an async function. Sorry, there's a comma here, and inside here you can now write your like your test logic, right? So but the first thing we're going to do instead is um we're going to do a simple function which is going to be responsible for deploying our smart contract. Now the reason why this is important, this is like this I think this was a very new feature because last time I used what's it called, the last time I used Hardhat, it was not exactly available, right? But so the whole idea of it, right, is you want to ensure that you don't want to like deploy your contract every single time you want to run a test case, right? So what the load fixture helps you do, right, is you can write your deployment function or your deployment logic in one function, right? And you can return some certain arguments, or you can return all the variables you're going to be using in your test cases, right? And using the load fixture, you can have access to that particular function which runs the deployment script. So each time you run a test case, right, you already have that function is going to like run the whole deployment logic, right? And return to you the different variables you want to use within that test case, and you can simply just import it and use it. So we're going to call this function deployment fixture. We're going to call this function deployment fixture. And the first thing we want to do right within the deployment fixture is we want to get certain accounts we're going to be using for deployments and testing. So we want to get the first account we're going to call owner, the second we're going to call address one, the third we're going to call address two. So we're going to be needing three different addresses or three different accounts or three different signers, right? So these are going to are basically what we're going to be the different accounts we're going to be using to like call our test cases and do stuff, right? And we're going to get it from the ethers.signer, sorry, dot get signer, dot get signers. So basically, when you call the ethers.get signers, the get signers method basically returns different addresses to you, and you can, I don't know how many addresses, what's the maximum addresses, but you can get as much addresses as you probably need for like running your test case. And once we do that, right, the next thing we're going to probably do is we're going to deploy our token. So let's just call this ERS20, right? And we want to like deploy this. We're going to use the that should be the deploy contracts method available within the ETAS library, right? And what we're going to be supplying, first of all, we're going to be supplying the contract name. That's the name of the contract module we want to deploy. And for us, that's ERS20, right? So we're going to be supplying ERS20. And the next thing we want to pass in into an array is the arguments that we're going to that our contracts accepts, right? So if you check our ERS20.sol and you check our constructor, you see that we accept four major arguments. Is it four, three, one, two, three major arguments rather. We accept a name, we accept a symbol, and we accept a decimal. The name is a string, so we're going to pass in our name, which we could just call let's call the name blockchain UNN, right? And we want to pass in the symbol, which we're going to call BUNN. And finally, the decimals, number of decimals of our sensitive token, which is going to be like 18. And I think that's all the arguments we need to deploy our contract. Now, the last thing we're going to do is we're going to use, I think that's called weights, ERC20 await deployment, await deployment, or um, sorry, I've actually forgotten some of all these methods, right? So, but let's check the Hardhat documentation. That should be okay. Testing contracts. So after deploying your contract, yep, particular function I'm looking for, I can't find it. Retesting contracts, right? Mm, Just like the latest documentations. I can't exactly find what I'm looking for, right? So it's just realized the first mistake I actually made is this is actually supposed to be an async function because deployment fixture, this deploy contracts basically we have to wait for the deployment to be returned before we can have access to like the contract factory, right? So this has to be await etas dot deploy contracts. And ERS 20 is supposed to have, yep, wait for deployment. Yeah, that should be it. ERS 20 dot wait for deployment. And basically, what this is going to do, right, is after the deploy contract method is called, right, and the contract factory is returned. So basically, what we are doing is we want to wait for the deployment to like be concluded or like the transaction to be finalized in the block, right? And once we do that, we want to simply return um, all the things we're going to be using. So I'm probably going to be using the ARS20, the ARS20 property. Sorry, the contract factory, basically the contract initialization, which is ARS20. I'm going to be needing the three addresses, address one and address two. So this is basically all we need to do, right, for our fixture. So each time we like call this fixture, we can get basically the contract is deployed and would have access to like all these variables we just returned. Now, having done this right, we could basically just start with our first um our first test case, right? So we could start with what's the first thing we'll probably want to test. So when you check the constructor, right, you would see that when this when basically the contract is deployed, it sets the name, the symbol, and the decimals. Then it does something. It mints to the message of sender 1,000 tokens. So in the case of this particular function, our message of sender is going to be our first signer, which was returned by etas.get signers, and that's like the owner, that's the owner address, right? So this is going to be our message dot sender. This is going to be the address or the account or the signer that automatically deploys our contract. So the first thing I'll probably want to check is I want to check that these three properties were properly set, right? And we could just see we could check that it sets name, token, and decimals correctly. And what we're going to do is this is going to be an async function. And so what the person wants to do, like I said earlier, we want to get some of all these properties. So, but in this case, right, in this particular case, for this particular test case, we are probably not going to need the owner, the address one, or the address two, since we just want to check that the name, the token, and decimal was set correctly. So what we could probably do is we'll just say, I'm just going to get the ARS20 contract factory in itself, right? And we're going to say this is like going to be equal to, we're going to use this load fixture property we imported, the load fixture property, and the particular fixture function we want to like import is the deployment fixture. So once we do this, the next thing we're going to do, right, is we're going to get the name, the symbol, and the property. So the way we could do that, right, we could say constant name is equal to ERC20 dot name. Now recall that the reason why I can't call the name, the symbol, and the decimals correctly is that they are public storage variables, right? And if you remember what we taught you about public storage variables, we said that public storage variables like in Solidity automatically creates what we call getter functions. So you can easily like query for them just the way we did, right? So we're going to get the name, we're going to get the symbol, and we are going to like get the decimals. So these are the three things you need, right? The decimals, right? Name, symbol, and decimals. Now, the next thing we're going to do is we can just, I think we could use an assert or an expector. We could say, we could assert that our name, right, is equal to what name they use, blockchain UNN. So we could assert that name is equal to blockchain UNN. We could assert that the symbol is equal to BUNN, and we could assert that decimals is equal to like 18. So all we are doing basically is we're getting the name, symbol, and decimals returned from our token, right? Our deployed token. This is the initialization of our deployed token, right? We're getting these values, and all we are doing, right, is we're trying to check that okay, the values that were returned are equal to that the values we set initially. That's blockchain UNN, BUNN 18. And if the test passes right, we can assume okay, it means that um the test works right, or like the smart contract works as expected. So I'm going to just save this and we're going to head to our terminal, and you can run your test using the npx Hardhat test command, right? This is our test is failing, and what's the reason? Cannot read properties of undefined reading name. So cannot read property of undefined reading name. Why is that? Cannot read property of undefined reading name at 15.8. Okay. Trying to figure out what's wrong.
Yeah, can you hear me?
Yeah, I can hear you.
Can you hear me, Darlington?
Yeah, I can hear you. I can hear you.
Okay, so I think we might have to attach an await to each of the
Ah,
getter
I,
functions.
I keep forgetting that. Keep forgetting that. So we're supposed to
Yeah, so
wait
maybe
for
that's
this.
why.
Yes.
Because I think it returns a promise.
Yeah, I think that's why actually. Still feels. Wait, yes, 22. Okay, that's, I think we're supposed to wait for this. No, no, we are not supposed to wait for this. Um, wait, yes, 20 with this. Hmm, probably. Okay. The load fixture actually returns the promise, so it means we're supposed to wait for this. That's also the reason why it's probably not available. So, okay, object is not retrievable. A deployment fixture, personal document decimal structure. What am I doing wrongly? This is objects is not retrievable. All right. Let me see how they did theirs here. To deploy and you return this right. So basically, for your functions, you probably just await load and huge like I probably done this earlier today. I mean, see, object is not retrievable. Cannot read property symbol dots retrievable. Something not the long picture 739. What's that? All right, let me try to cross check something. Foundation. All right, can you guys still see my screen? Hey guys, can you guys still see my screen? Yeah, Henry, can you
Yeah,
see my
yeah,
screen?
I can see your screen.
Yeah. So okay, the issue was we actually supposed to await this to so this returns a promise to so we're supposed to like to wait for this to get returned, and that's the reason why we were running into that errors, I believe. Yep. So basically the array was not getting filled up, and so we actually not even having access to the owner's signature, which we're actually supposed to use to like deploy our contract. Apologies, I didn't bother to even check up on this before the class. Sorry for all the back and forth. But I think from now on, I'll just have to remember to keep up with my await 21 JavaScript. So the next thing we need to do, right, is we're going to check under deployment still. We need to check that the message to sender, that's the person deploying the account, right, receives 1,000 tokens. That's the total supply basically. First of all, we need to check that. Then the last thing we need to check is that the total supply is going to be 1,000, because if you check the means function, right, which brings us to what I said about assumptions, right, you need to be able to, first of all, you need to understand how your smart contract works. They need to try to cover every possible test scenario. For example, you check the needs contract, right? You will notice that it does two things. First of all, it increases total supply to like the amount that is being needed. Then secondly, it increases the balance of that particular person minting to like the amount being minted, right? So two things should happen. The first is that we want to check that it sets the total supply, it sets the total supply to like it sets the total supply correctly. You could just use that. So, but we know what the correct total supply is. So from our ERS20.so, right? Our total supply our total supply is going to be, if you scroll back upright, it's going to be 1,000 tokens, right? So we need to say, okay, this is going to be an async function, and so the first thing we need to do is we need to get our ERC20 property, obviously, right? And we're going to do that using the load fixture, and we're trying to like load the deployment fixture. Then we need to like get the total supply, which we're going to see total supply. We're going to see total supply is equal to our ETRs 20 that that should be what function is that again? Total supply, right? So we're going to call the total supply, and once we call that, right, we want to check, want to assert. We could also use the expect, right? You could say expect that the total supply we got returned, right, to be equal, we want it to equal like 1,000, which is like our total supply 1,000. So once we do that, we are probably going to save and check that particular test case. So once you can see that that particular test case passes, right? So next thing we need to check is we want to check still under deployment. We want to check that it means the total supply to, or let's say the initial supply, right, to like the owner. Let's use message of sender instead. So the message of sender, and that's going to be like an async function. And we'll want to check, first of all, we'll get like our extensive property. I want to use the load fixture property on load fixture method, and we want to load the deployment fixture. All right. Now, what do we want to check? We could check. What we could just simply do is we want to check. We could check the total supply. What the total supply is? We could get the total supply. There's 20. The total supply, and we could get the balance of the owner. So sorry, this time around we're going to import the owner to we're going to import the owner account, and we want to check constant balance to be, or you could say balance of owner. We could say await ERS20, and this time around we are calling like the balance of function. As you can see, it takes in an address and returns in 256. So I want to check the balance of, and the balance, we won't check balance of the owner, basically. That's the account on check balance of. And what we're going to probably do is we want to assert that total supply is equal to like the balance of owner. Right. And so once we've done that, right, you could see um, we've completed our token deployment function. But see, what I'm going to do is I'm going to nest the token deployments. What I'm going to do here is in here, I'm going to do another describe for just in here. We could just say yes, 20 tokens, right? And for this, we are going to see token deployment, function, right? And we're going to pass in everything we've done as regards to token deployment into that particular describe. Like I said earlier, I use the describe right to like categorize your test cases. And once you do that, it means we have completed our test cases for token deployment. Next thing want to the next test case you probably want to do, right? Which the rest of the functions fall under is want to test for the transfer function, for the approve function, for the transfer from function. And obviously you don't test for private functions, right? So private and internal functions are called by the external functions. The external functions are majorly what we want to test. So we're just going to like I'm going to write tests for just those, right? And we're going to describe token transfers. Yeah, for one test the transfers, right? And this is going to be like normal function. That's wrong. Yep. So you could use whatever you want to use, an arrow function or a normal function. I just use whatever comes to my head. Then for the token transfer rights, we are probably going to start with it transfers correctly, right? We want to first of all test the transfer function. I want to test this first. So I'm going to check it transfers correctly. It's going to be an async function. And so for the transfer function, first question to always ask is what are the assumptions involved? What are the things I want to check for? Now, if you check the transfer function, right, it delegates the whole logic to this transfer private function. On this, I want to focus. So the first thing we want to check for is we want to check that we could check that in the case where you supply a zero address, the transfer fails. But let's keep that for now and focus on like the more major functions, right? So, but I want to list out all the assumptions involved. So, we assumptions involved you could test for is that um if the recipient is a zero address, right? The transfer function is going to revert. And I think there's you could actually do that using the expect, then you could see to be, I think, reverted. You could use that. We could use that to test for it. So we're going to write one test basically to just test for one of all those reverted steps. Then you could also test for the fact that in case the user does not have enough balance, right? The function is also reverted. Then the last things you probably want to check for is that the balance of the sender is deducted and the balance of the recipient is added up. You could also test that specific events are emitted, right? These are like all the assumptions you probably want to test for like proper code coverage. So, but let's test for some of the reverted cases. So the first reverted case is that if the recipient is a zero address, then it should get reverted. Now, how are we going to do that? So first of all, we're going to like get our addresses. Okay, this is going to be it reverts for zero address if recipient is it reverts if recipient is zero address. All right. So we want to get the RS20, probably want to get the owner because one sent from the owner. I think that's anything we probably need to get. Then this is going to be want to load the fixture. This is going to be deployment fixture, right? Okay. So, what's the next thing we probably want to check for? Sorry. Now we want, if we want this to be accessible by all functions, it means that we need to put this in our parent describe. So we're going to put this here instead. We're going to put this here instead so that it is accessible by every single function, every single describe, every single test case. Now, once we do that, right, the next thing we probably want to do is we want to um call the transfer function on the ERS20, right? The transfer function. But this time around, I'm going to pass in a recipient as a zero address, and we're going to pass in an amount, obviously. So the first thing we want to do is we want to connect to the accounts. So there's the connect method, which is available for your test cases, right? So basically, what you use connect to do is to connect the account or the signer you want to use for that particular transaction. So we want to use the owner for this particular transaction, right? And we forget this is going to be an await statement. So next up, we want to call the transfer function, and we are going to pass in a zero address, and we are going to transfer to. We're going to transfer. Okay, that's 1,000 tokens, so we could transfer 200. Transfer 200, and once we do that, right, we could say we want to expect the transaction, right, to like be reverted. I think there's an to be reverted. That's supposed to take string message. You're supposed to pass in the revert message into one. I think it should be here, right? So the revert message you want to expect, right, is that the recipient is zero address. Want to expect that it's the transaction basically is like reverted, and it's reverted with the recipient is zero address needed. That should be reverted with, I think it's reverted with rights with this. And let's see if that works. Unsupported addressable value. What am I missing out? Let me check what that's. Let's try method. Expect dot to dot be reverted. Let's see what that accepts. Try
Can you hear
method.
me? Can you hear me?
Yeah, yeah, I can hear you.
Yeah, I think the argument you passed for that address zero. I don't think it has to be zero. It has to be like the actual address zero on the Ethereum blockchain. You get, but
That
you just passed in the value zero.
okay, the exact zero address on the Ethereum blockchain should that be zero x
Yeah,
zero.
maybe that should be it.
Okay. Oh, okay. Let's try with that then. Still gets where's the error coming from? Unsupported address, value equals zero code. That's just Ethereum zero address. Let's check how that's done. Already have didn't exactly have time to write this beforehand.
Okay.
So that's why I'm going to. And in most cases, use Power for my tests instead. There's a SDX0 is supposed to work in my test, okay? Allows zero. Oh, okay. Okay, there's an eta such constant that's added zero. Oh, I see. So this is this. I think an eta that constant. I don't think that's still available though, because if it is, we are supposed to like have that pop up. Let me see. Check the hard has. Let's see if we have the task constant available. And if there's two, don't just use additional test helpers. So, but if we follow what they are doing here, right, means we probably need to use an additional test helper like Open Zeppelin to like get their constant to zero address. Right, let's just do that then. That's taking up our time. Sorry, this is taking a long while. The network is not exactly very strong. Okay, this is now beginning to speak forever. Finally. Alright. So in here we're going to think there's the constant method first. And we want to use Super Zeppelin slash test helpers. Alright, so with that we could use constant the uh, zero address. Yep. I think that should work. And this is going to be in here. So let's just cut this a bit. Not to be reverted with the error recipient is zero address. Now let's try to run the test and see if it passes. Not this. If you have a test filling, is VM exceptional potential reverted reason string recipient is zero address. Yep, that was the whole idea in the first place. Expected it to revert. Mhm. Okay, there's an open Zeppelin helper we could use. They expect to revert. You don't pass this in, right? Oh, I see. Right. So when you use the await, right, it tends to like wait for the promise returned by calling this particular function, right? So but the expect is actually supposed to like have simulated the transactions and then ensured it's reverted with this particular error. And so having done that, right, we could also do for what other so there's still like the sender is zero address, which should obviously be the same thing, but this time around it's the sender being the zero address, right? So and then we could also test for the insufficient funds. I think that one is actually very important because we want to ensure that um senders or people sending money, right? Users cannot send more money than they have access to. Right. So for the second we could just copy and paste, right? So it reverse if sender is zero address, and for that we're going to use constant dot zero address here instead, and we could use address one here, and this is going to be a valid address. And so we expect when you call this right, it's going to revert. Third piece is going to be it reverts if if like sender's balance if senders balance, or let's simply say if sender has insufficient funds. If sender has insufficient funds, sorry, this is going to be sender is zero address, right? That's the return. Sender is zero address, right? So it reverts if sender has insufficient funds, right? And this is going to be almost the same thing, right? So let's just copy this. It's going to still be the same thing. But this time around, we want to send 2,000 tokens. But recall we just have a total supply of 1,000 tokens. So he shouldn't be able to send 2,000 tokens. And in this case, right, we are connecting the owner signature. And we want it to revert if like he's trying to send more money than he has, which obviously he doesn't have up to 1,000 tokens. Sorry, we need the owner here. Then we need address one. And this is going to revert its error. What's the error? Insufficient funds. Insufficient funds. Now let's check if this goes through. Right, so those set of test passes, right? So the next thing we want to check is we want to check that the transfer goes correctly. And the way we could check that is that we want to check first of all that the balance is like increased, or yeah, balance is increased basically. So we're going to call that particular test case it transfers correctly. And this is going to be an async function. And so obviously we want to get this owner address one. We could just just multiple sending, and we we're going to await the load fixture, deployment fixture, right? And what do we want? So we want to call um the transfer function. First of all, let's connect the owner, the one with the funds, and we want to transfer. So we want to transfer to address one, and we're going to transfer 200 tokens. We're going to do the same thing, right? So we're going to still connect to owner, and we want to transfer to address two 300 tokens. Now, when we run all these transfers, right? But the next thing we want to probably do is we want to expect that if you check the balance, if we check AWTR's 20 dots, the balance of the owner, the current balance of the owner at this point, right? We want to check that it should be equal to it's going to be called 500 tokens, right? Because we know that the total supply, total amount here is 1000. So if it sends 300 plus 200, that's 500. It should be left to just 500. And then we want to check, I'm going to check that if you get the balance of, if you get the balance of address one, right? We want to check that it should be equal to 200. And if you check the address, sorry, the balance of address 2, we want to be sure that it's equal to 300. So this should be all the balances. So the first one basically checks that the owner's balance was reduced to 500. The second one checks that the address one balance was increased to 200 and address two's balance was increased to 300. And this should complete our test keys for token transfers, right? So let's see if all our test passes and the all of them passes. So now we can move on to writing for the approve and the transfer. That's going to be our last test case, right? Our last test suite. So we'll test in this case, we're going to be testing the approve function. I'm going to be testing the transfer from function. I think that's just both of them, right? So we were going to call this test suite. Let's see. We need to describe this as token approval and transfer. And all right, so I want my this thing to be uniform. Let's just use normal functions for describes and async functions for test cases. You can use whatever you want to use in this case. This point, you could use whatever you want to use. It would work. So just know that your describe functions are not async, since you are not awaiting anything, and your test cases need to be async, since you'll be awaiting the return of the promises from the call. So the first test case we want to test for, right, is that it approves correctly. It approves correctly. And this is going to be an async function. Okay. And basically what we want to do is, as always, we want to start with getting our fixtures. Here's 20 owner address one. Um, those That is enough, in my opinion. So await load fixture and deployment fixture, right? And the next thing we want to check, right? First of all, we want to call the approve function, but we're going to connect the owner, right? So the one with the phones. And we want to call the approve function. And the approve function takes in what the spender and the amount. So our spender is going to be address one, our amount is going to be 200. And what we're simply going to do is we're going to assert or check that um okay, first of all, before we do that, right, we could just say constant allowance is equal to await here's 20 dot allowance, and we want to check the allowance of the owner and address one. Remember, the allowance takes in two variables. So you need the address that is allowing and the address that is allowed, and to return the amount. So we're going to pass in owner and address one. And so basically what we're going to check is that allowance is equal to 200. That's going to be our first test case. Now our second test case, right, is going to be that it approves and transfer, it approves and spends correctly. Spends correctly. All right, let's first of all check our assumptions, right? That's always very important if you want to like cover as much as you can cover. So if you check your approve function, right? Something we did not check for is that the spender is not a zero address, which we could easily check for, right? Then other things we need to check for when we call transfer from, we want to check also that the recipient is not zero address. They want to check that this guy here is not sending more than he is allowed to spend. That's the other thing. And I guess every other thing we'll probably check because at the end we are, so we're going to also check that at the end. Probably we can do that in one function, right? That the allowance of that particular sender is deducted, but every other thing is delegated to the transfer function, which I think we've meticulously checked. So for it approves and spends correctly. Before then, let's check for some of all those things. For approve, right, we want to check. For approve, we want to check that the spender is not a zero address. And we could just do that. We already have a code that does that, right? Let's just copy and paste because of time. So I'm going to say it reverts if spender is zero address. If spender is zero address. And so in this case, we are connecting owner and we're calling approve. And this guy here want to approve. We are going to use like a zero address. And we're trying to approve money to him, right? So expect it to be reverted with what was the error. Spender is zero address. That's what we want it to be reverted with. All right, so I'm going to paste that in here. I just want to know if we could just remove that. Then I think that should work. So that checks is that system that zero address. Then next up, it approves correctly. Okay. Then the next thing you want to check is the transfer from logic. And you want to check that if it's approved, right, that it transfer from works. But first of all, we need to check that the recipient is that it reverts if recipient is zero address. So we could just copy this and we could say it reverts if recipient is zero address. And obviously, what we will probably need to approve beforehand because you can't call transfer from without approving. So we want to await ERC20 dot connect owner and we want to approve okay owner address one. We want to approve address one to spend 200 tokens, right? And okay, approve address one spend 200 tokens. And once we do that, right, we can now call the transfer from function. And we're transferring from the person calling this. Okay, the person that will be calling this, right, is going to obviously be the owner. No, it's not going to be the owner, sorry, it's going to be the approved address, which is address one. And we want to call the transfer from, we're going to pass in the owner, then we need to pass in the recipient. A transfer from takes in the owner, the recipient, and the amount. So, but the recipient in this case now, we're going to pass in a zero address. We're going to pass in a zero address, right? And the amount you want to send is like 100. Okay. And let's clear this. So well, we check. Let's check this is correct, right? So first of all, we approved this guy to spend 200 tokens, and then now we are trying to connect his address. Okay, so it means the transaction will come from this account, and we are transferring from the owner, right, to a zero address 100 tokens, and we expect it to be reverted with what recipient is zero address. So this is going to be recipient. Recipient is zero address. So before we move forward, right, let's check that all this is passing. So if you know to try to solve that before we go forward. Right, we have two issues. So your strength is not defined, just your strength is not defined, your strength is not connect from is not a function. Why is that? That's for one line. It's two failing. So your strength token, your strength token reference is 77, line 77. That's weird because I just defined it here. What am I missing? What am I missing? My head. Really, okay. Await years 20 that connects the owner. That should be defined though. Let's let me comment this and let's start with that. So this is film and it says years 20 is not defined. Okay. Which it obviously is. So what's the problem? What's the problem? Are you still on the call?
Yeah,
Yeah,
you're on the call.
yeah,
Okay, so yeah. So I need you guys' eyes because I'm actually not eating, so my eyes is actually turning me. So I don't know where this error is coming from. The twenty is not defined. Why is it not defined? Seriously looks defined. Um, okay, let's say something. Yeah. See, somehow this is no reference in this, which is weird. Okay, that's actually weird. It approves correctly. Okay, let's say something. I have no idea why that is happening. Did I use an O instead of it is zero? Well, that works now. So let's go back to this to check what was wrong with this particular one. Um, I have no idea if it's the same thing, but if it is, let's just replace this again. Plenty that connects transfer from is not a function. Okay, I see why. So, 20 is not defined. Why is it not defined? So here's 20 is not defined. Okay, 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 so here that's we're trying the address now. And okay, transfer from is not in function. Oh, that's strange. So we always use camel in snake is okay. All right. So now we've done that. Where are we currently now? It's reversive recipient zero address. So we just checked this. The next thing we want to check is we want to check this this particular statement that the amount that this particular guy is trying to send does not exceed his allowed budget. So we're going to still use the revert thing. I'll just copy and paste. We did from there because of time. So we're going to see it reverts if amount is greater than allowance. Okay, reverts if amount is greater than allowance. And what do we want to do? First of all, obviously, we're going to call approve. Approve is 200. In this case, we're using a valid address. We're going to be using address two. So I'm going to add a third address here. We're going to be using address two, right? And we have 200 that was approved. In this case, let's try to send 500. And so this should revert with this with amount exceeds allowance. It should revert with amount exceeds allowance. And let's just check that passage because test is now beginning to review. Yep, that passes. All right, then once we've taken care of those assumptions, the last thing we probably need to do now is to now take care of the major transfer from. So once we take care of the major transfer from, right? Amount exceeds allowance. Yeah, so we need to take care of the major transfer from. All right. So sorry, not yet. So we're going to say it transfers. Let's just say approves and transfers correctly from sender. Okay, let's just leave it short. It's going to be an async function, and we'll get these values first of all. There's 20 now, address one, address two, right? Then wait, load fixture, deployment fixture. Okay, we want to check. First of all, obviously start with approving, right? So we could also create a fixture for this if we need to. All right, so let's just move on. Connect owner and we're going to call approve. Approving address one to spend 200 tokens as always. And we want to, what do we want to do? What do we want to do? What do we want to do? We're going to, we're going to basically call the transfer from function from address one. We want to call transfer from function. Our sender should be owner. Our recipient should be address two, and our amount should be 100. Okay. Now what we're going to be doing is we're going to be checking the balance of we're going to be checking the balance of the owner is deducted. We're going to be checking three things. We're going to be checking that the balance of the owner is deducted. We're going to be checking that the balance of the recipient is increased, and finally we're going to be checking that the allowance for address one has been reduced. So first of all, we're going to expect that awaiting ERC20 that balance of our spender is the owner, right? You want to expect that it is equal to 900. So if he has 1,100 goes out of it, he should have 900. Next thing we want to do is we want to expect that the balance of address two, who is the recipient, right? That's his balance is equal. His balance is equal to what 100 seconds. All right. Then finally, the last thing I want to check for. I want to check that the current allowance, the current allowance of the owner on the address one. I want to check that it is equal. I want to check that it's equal to what? It needs to be equal to 100 because he already spent 100 tokens, so he has 100 allowance remaining. And if all this is correct, right, we can assume, okay, yeah, approach and transfer works correctly. So let's see. Hopefully, we don't run into an error. Yep, that works. Okay, so this and actually way faster than it used to be. All right, so once we've done that, right, I believe we've covered a large percentage of our code, right? Definitely not going to have 100% coverage, but I think we've covered a lot. So obviously, when you cover transfer and total supply, the initial deployment, you already covered these two private or internal functions, right? So at this point, I could say we are almost halfway done. Okay, one thing we didn't cover, right, was the emitted event. You could probably just try that out on your own. And this should be our test piece, right? Now, next thing we want to do is we can check code coverage. So there's this tool, there's this tool, just search code coverage, yes, solidity code coverage, npm, an npm package called solidity coverage. So basically, you can use it to like check the coverage for like your solidity codes, right? How much of it was covered, and we are going to be using this as it has no okay hidden link. I think you could put the npm install solidity coverage. So do npm install Steve the solidity. What is it? Me? I'm making typos. Solidity coverage. And let's try to install that. All right. So once we do that, right, we need to add it to our Hardhat config. So just simply come here and require it. Solidity coverage. I think that's about it. So next time when we like run our test case, right, we should have no. Let me try this again. Okay. Um, just special npm command for that. Maybe isn't okay. Sorry. That's coverage. Yep. So as you can see, right, when you run the command to run is basically the npx highlight coverage. And once you run that, right, you can see it emits like a little table with the results of your coverage. And as you can see, yes, for our statements, we covered 100% of our statements. That was amazing. For the branching, we just covered our 85.71. So that was not 200. Well, functions, we covered all our functions, right? All our functions was executed during the test. And for the lines, you can see we covered 100% of the lines too. So as you can see, that was like a good test. That was a good unit test, right? Well, let's say this was a contract I want to deploy into production. I wouldn't want to end here, right? I could still go ahead to do other tests. For example, I'll probably try to force my test with random variables. That's basically dynamic analysis, right? Using a tool like maybe Foundry or Echidna, and I could probably go ahead, right, to get an audit, to hold the bug bounty and whatever it is, right? So the more stuff you engage in, right, the better your chances at having more secure codes. And we're already way behind schedule, right? We're already way behind time. Very sorry. I didn't exactly write the contracts beforehand, right? I I thought it was I had everything covered already. It's been a while since I wrote tests using Hardhat. It's been mostly Foundry since that's like very, very close to what I use with them. It's on StackNet. So apologize for all the back and forth, right, with JavaScript. But I think we learned something. We learned something valuable, right? We could write a test. I don't know if we need the code. Should I push it to like GitHub and probably send the link?
Yeah, yeah, yeah.
Yeah,
That
we
would be
would
very
need the code. Yeah, we need it.
cool.
All right, all right. I'm going to make that available. So I don't know. Is there any questions? Did we like follow? Is there anything you're probably confused about? Something you want us to cover?
Well, to me, it's very clear. It's very, very clear. I followed it well.
All right, all right. So I guess we're rounding up. So let me just push this. Uh, uh, okay. Why even now we get to know here? So yeah, right. Um, um, like, it's and oh, it's the only parts I ignored. Yep, it's commits. Um, uh, oh, okay. I'll do it again. Alright, I think I just pushed that now, so we just have access to that here. That's on the right stuff. Okay. Mhm. Yeah, where we? Yeah. Okay. Oh yeah, I just saw Ethereum. Okay, that's like the zero address, right, on Ethereum. But I think we're going to still have issues with that because that looks like a, a big int, right? I don't know, but that integer, I don't think it's supported by JavaScript, so I'm probably going to like still have issues with that. So it's best to just use like the test helper we just used from OpenZeppelin. And I think that'll be it from mine. Thank you so much, guys, for like coming around. I think it's just Victor, two Victors on the call, right? And I guess we'll meet on Sunday for the class on Foundry, testing in Foundry, right? And
Yeah,
do
thank you
have an
very much,
amazing
sir.
night ahead.
We'll meet on Sunday.
Yeah,
Thank you very much.
right. You're welcome.